Hello, today we are going to do a short tutorial using MolView to draw organic molecules. So one of the worksheets I use with my class is this naming alkanes worksheet. The first part is you're writing the name given a structure, which you would just write your name, type your name out in this corner. And then the second part is given the name, trying to draw the structure. So there's two ways you can do this. If you are doing this on paper, you can use bond line, angle formula, and the structural formula and just draw it out. If you are taking pictures of your work, you can upload your pictures to the Google document, or you could use MolView to help you. So this first one I'll help put you with is 4-ethyl octane. So we go to MolView, molview.org. Don't need to really worry about anything on here. Just click close. And it always defaults to the structure of caffeine for whatever reason. But if you clear that out, you've got some options here. You've got single bonds, you've got double bonds, triple bonds. You even have a wedge and a dash or a hash to represent the stereochemistry, or things that exist in 3D. You also have different rings. So they got benzene rings, cyclopropane, cyclobutane, cyclopentane, cyclohexane, and cycloheptane. You could make larger rings than that, but you would just have to do it manually. You can also just click a carbon chain, and you can easily stretch out based off of how many carbons you want. So for this one, let's say I want octane, which is 8 carbons. It stretches it out for me. But notice it counts the number of carbons from that first spot. So even though I went 1, 2, 3, 4, 5, 6, 7, 8, 9, you saw that the numbers only went from, they started counting on the second carbon, which is kind of weird. So if I wanted to add 7 carbons to my initial carbon for a total of 8, this would be an 8 carbon chain. Now, a couple of features here. You can click this CH button to toggle the skeletal versus the bond line structure formula. You can also click this to center. And then you can also clean up the structure. Sometimes it'll change things, sometimes it won't. This one just inverted things. It doesn't really matter. You still get the same structure. But when you start having branches sticking off your chain, that's when this cleanup button is useful. So again, I'll go through. The other way you can do it is if you just add the individual parts, you can add it that way as well. So I've got 1, 2, 3, 4, 5, 6, 7, 8 carbons. And then on the 4th position, I needed an ethyl group. So I count, I've got 1, 2, 3. Here's the 4th carbon. And ethyl is 2 carbons, so I'm going to stick a branch off just like that. Now, I chose to make the second carbon stick off to the right, but you could have also had it stick off to the left. It's really your call. When you toggle back and forth, you can see the skeletal structure as well. You could also click clean, and that will just kind of clean up the structure, make sure the angles are all right for you. This time they put the ethyl group sticking down, just in an equivalent way to write the same molecule. Now you can also click 2D to 3D, and what it'll do is it will make this structure for you in 3D, so that way you can observe it, which is cool. So that's really useful, but the other good thing about this is that it allows you to download a picture version of this. So you can export a structural formula image, and by doing that, it saves it as a PNG. So PNG file, I can just save this as 4-ethyl octane and click save. And if I wanted to, I could come in, insert, go to image, upload from computer, and then this folder, I believe I saved it in here. So here we go. Boom. Now, obviously, that's a huge file, so you might want to shrink it down. You could also go the easier route if you have the ability to screenshot. I have the ability to use the snipping tool to screenshot. I like that. So I can just highlight and then paste my bond line structure right in there. I could also do the same thing for the skeletal structure if I feel the need to do that. I think bond line structures are easy to work with, but it is really easy just to paste your structures right in there so you can see the comparison between both of them. Another way I worked through this is I made a table, so you don't have to do it this way, but if you want to keep yourself organized, you can make a table. 4x4 on one side, we've got the structural formula. The other side, we have the bond line angle formula. And then you can just paste in your boxes into there just to keep it organized for yourself. Okay. When you want to go on to make the next one, you hit the trash can and you should be able to edit from there. You can also add in other elements. So eventually, when we start dealing with more complex molecules, you need to add in an oxygen, specifically like a carbonyl. You can add a double bonded to the O. And then if you click that, it causes all the C's to go away, and you see the bond line angle formula. And then when you click again, it repopulates with all the H's. All right, it's a pretty useful tool. And then again, you click 2D to 3D, and then you can see what this molecule looks like. You can also, if you're interested, go to the information card, and they usually give you a name and some updates. So it tells you this particular thing is called 3-hexanone, and it tells you some usages. It tells you the molecular weight, the percent composition, and then the overall molecular formula. Some of these other things are not very useful for you at this point in time, but it is a cool little program to play around with. If we go back, you can also look at different 3D models. So this is the ball and stick model, but I could just go with a stick only model. There's van der Waals spheres if you're trying to look at like electron density and see how those electron clouds impact things. There's wireframe, and then there's also just regular line formulas. I prefer the ball and stick model. It's really easy to see all the atoms and where they are at in 3D space. And that is about all for this tutorial.